Algebraic expressions is guaranteed to come up in your maths paper whether you're doing foundation level or higher level. I'm now going to go through everything you need to prepare yourselves for your exam, from notes and theory to actual questions to get you guys to fully understand the topic. We're going to start with index laws. Now there are 4 laws that you need to know for your exams. To multiply indices together, we have to make sure our base number is the same, and then we can just add them together. So for our question here of a to the c times a to the d, our answer would be a to the power of c plus d, since we add our indices together. When we divide, we do the opposite. Instead of adding our indices together, we're going to subtract them, and we get a to the power of c minus d. When our whole indice is covered by a bracket, and that's raised to the power of another indice, we multiply our indices together. So we get a to the power of c times d. In our last law, we have 2 integers multiplied by each other in a bracket, and that whole bracket has been raised to the power of c. To answer this, we raise both integers to the same power, the power c, giving us a to the c times by b to the c. Now that we know these 4 index laws, we can apply this to some questions. For question A, we need to use our first index law. Since we're multiplying, we need to add our indices together, so our answer would be x to the power of 7, since 7 is 3 plus 4. In part B, we have a fraction with some numbers in front of them. An easy tip that you guys can do in these kind of scenarios is to move the numbers outside of the fraction. For example, in this case, I take out 4 over 2 and I multiply that by y to the 6 over y to the 3. We can split our fraction in 2. From here, let's start with our first term, 4 over 2, which is equal to 2. Now our second term uses our second index law. When dividing, we need to subtract our powers, leaving us with y to the power of 6 minus 3, which is just equal to 3. And finally, we can remove our multiplication sign and write this as 2y to the power of 3. Question C is using our third index law. Question C is using our third index law, where we have z to the power of 2, and that whole term has been raised to the power of 4. In this case, we multiply our indices together, giving us z to the power of 4 times 2, which can just be written as 8. For question D, we have a combination of our third and fourth index laws. Let's start by using our fourth index law. We can raise both x squared and y cubed to the power of 3 separately. Now from here, we use our third index law to multiply our indices together. For our first term, we have x to the power of 2 times 3, and for our second term, we have y to the power of 3 multiplied by 3. Our last step now is to multiply our 2 terms together. Now let's move on to some more complicated index laws. Again, there are 4 that you need to learn. Let's go through them now. Our first law is when we have any base number raised to the power of 0. The trick here is any number raised to the power of 0 is equal to 1. Whether it be 2 to the power of 0, 5 to the power of 0, or 100 to the power of 0, the answer is always 1. Our second index law is when we have a negative indice. The trick to turn our negative indice into a positive indice is writing the reciprocal of our term, which means writing 1 over our term. In this case, we get 1 over a to the power of c, and that gets rid of that little minus sign. Our third index law is when we have a fraction as our indice. We can write this as the c root of a. For example, if c in this case was 2, we'd have a to the power of half, and that can be written then as the square root of 2. Our last index law is when instead of having a 1 as our numerator, we have another number. We call it c in this case. This is very similar to our third index law. However, all we do here is raise a to the power of our new numerator. For example, if this was a to the power of 3 over 2, this would be equal to the square root of a cubed. Let's now put this into practice. In question A, we need to simplify x to the power of 2 over 3. We can use our fourth index law to solve this question, and that gives us the cube root of a squared. Looking at question B, the first thing I would recommend to do is to get rid of our divide sign and write this as a fraction. So we get 36x squared over 6x to the power of minus 1. From here, we'll use our trick to separate our fraction, taking our numbers out and leaving our x terms separately. Now the question becomes a lot more simple. We'll start with our first term, which is 36 divided by 6, and that gives us 6. And for our second term, we have x to the power of 2 divided by x to the power of minus 1. In this case, we have to subtract our powers since we're dividing, and we get x to the power of 2 minus 1, which is equal to 3. Lastly, we get rid of our multiply sign and we get 6x to the power of 3. In example 3, we're told that s is equal to t squared. This doesn't actually change that much. All we do is sub in t squared wherever we see an s. So for part A, instead of s to the power of 2/3, we have t squared to the power of 2/3. From here, we use our index laws, and we know we need to multiply our two indices together, giving us t to the power of 4/3. For question B, we sub in t squared, and we get t squared raised to the power of -1/4. Now guys, what I recommend you to do when you have a negative sign amongst a question like this is to deal with it first. As we know, to get rid of that negative sign, we write the reciprocal of our number, which is 1/t squared to the power of 1/4. From here, we can leave our numerator of 1 alone, that doesn't change, and for our denominator, to simplify it, we again use our index laws and we multiply our powers together, giving us 1/t to the power of 2/4. Many of you would give this as your final answer, but you're forgetting one more thing. We can actually simplify 2/4 one step further, and we get 1/t to the power of 1/2. That's all of indices covered now, guys. Now we can move on to expanding brackets. To expand brackets, you have to multiply each term in our first bracket by each term in our second bracket. An easy method for you not to forget any terms is to draw these handy arrows on your question. They tell us what we need to multiply and we can tick them off as we go along. So for this question, x plus 2 times x plus 3, we can look at our first arrow first, and that tells us to do x times x, giving us x squared. Now staying with the top two arrows, I'll move on to the next one. We have to do 2 times 3. Moving to the bottom now, we have x times 3. And our last arrow is 2 times x. We don't stop there, guys. Now we need to collect like terms together and try and simplify this. You can see there's only one x squared, so that means we can't simplify this any further. Let's write that down. Now let's look at our x's. We have 3x and 2x. They can be added together to get 5x. And lastly, we have 6. There aren't any other numbers on their own, so we write 6 down again. Now that you know the basics, let's try out some questions. For part A, let's leave 3 to a side for a second and focus on our two brackets. To multiply these two brackets, we do what we did in the previous example. Drawing our lines on, we start with p times p, next we move on to 2 times p, then 3 times p, and lastly 3 times 2. Again, let's leave 3 to the side for a second and simplify our bracket. This is very similar to the question we just did, where only our p terms need simplifying. We can do 2p add 3p, and that gives us 5p. The rest of the expression stays the same. Our last step is to bring our 3 back inside the bracket. All we do now is times every term by 3, giving us 3p squared plus 15p plus 18. Part B may look a bit tricky, but there's an easy way to tackle this. We have 3 brackets, so let's start by multiplying only the first 2. We're going to multiply the answer we've just got now by the third bracket. So we have q squared plus 3q plus 2 times by q plus 3. Again, we need to multiply every term in our first bracket by every term in our second bracket. Our last step is to collect like terms again, and that'll give us the simplest form. You now know how to expand brackets. Let's move to factorizing. An easy way you can think of factorizing is it's the reverse of expanding a bracket. We're simplifying the bracket. To do that, we look at what we can divide all of our terms in the bracket by. We basically need to find a term that we can divide every term in our brackets by. For example, you can see here we have 4x plus 24. Now you can divide both terms by 4, and whatever we divide by, that comes out of our bracket. So we can rewrite this as 4 bracket x plus 6. But for example, if you have x in both terms, if you had 4x plus 24x, instead of just taking 4 out, you can bring the x out as well, since it's common in both terms. Now, when we have a quadratic expression, that's when factorizing can become a little bit more tricky. But again, there's an easy method for you to collect all of them marks in your paper. Let's look at what's written down below. To factorize quadratic expressions in the form ax squared plus bx plus c, we first need to calculate the product of a and c, and then we have to find 2 factors of this number that will add to get b. From here, we'll rewrite our initial expression and replace our bx term with the two new terms we found. From there, we have to factorize our first two terms of our expression and our last two terms from our expression. That may sound like a lot of information to digest. Let's now go through an example to really put this to the test. In question A, we have x squared plus 5x plus 6, and we have to simplify this. Our first step is to label our A, B, and C. As you can see, we get A to be equal to 1, B equals 5, and C equals 6. Now remember, our first step is to multiply A and C together. Now we need to find two numbers that will multiply to get 6 and times to get our B term, which is 5. In this case, we get 2 and 3, since 2 times 3 equals 6, and 2 plus 3 is equal to 5. Now our next step is to replace our B term with our two new factors that we've just found. So by getting rid of our 5x, we can replace that with 2x plus 3x. Next, we have to factorize our first two terms and our last two terms. Starting with our first two, we can take out x from both x squared and 2x, so let's write that down. And from our last two terms, we can take out 3 from 3x and from 6. A very easy way to see if you're on the right tracks is your two brackets that you see here should have the same numbers in them. We know we're doing fine so far since we have x plus 2 as both of our brackets. Now the last step is to first write down our bracket, which is x plus 2, and our other bracket is going to be our numbers outside, which in this case is x plus 3. And there you have it, guys. Now you know how to factorize quadratic equations. You've now made it to the end of the video, guys. That's all you need for algebraic expressions, whether that be in foundation or higher tier papers. I hope you guys found this video useful and got something from it. If you did, make sure you drop a like on this video, and I'll see you next time.